We've all been there. You try to scroll through a spreadsheet that's grown too large, and the whole computer whirs, the screen freezes, and the program crashes under the weight of the data. You likely already understand the basics of how this information is stored. It lives in a grid where horizontal rows hold individual records and vertical columns represent specific details, like a student's name or their grade. To handle millions of those records without a crash, professionals use a relational database. It functions like a heavy-duty grid, but it organizes data into separate units called tables. Moving your information into a database allows you to automate your work and keep your data secure, even at a massive scale. When you use a spreadsheet, you click a cell to change it, but in a database, the information is locked away in an invisible engine running on a server. You can't just point and click to see what's inside. To get the data you need, you have to send written instructions to that engine using a language called SQL. Think of it as a series of highly specific notes you slip under the engine's door. Let's look at this diagram of a data table to see how we write those notes. We use the select command to tell the engine which columns we want, and the from command to tell it which table to look in. Because these tables are often massive, we can use the limit command to ask for just a few rows at a time, which lets us safely preview the data without overloading the system. Writing these basic notes allows you to programmatically request the exact data you need, replacing a manual search with a single written command. We can refine our requests using a command called where. Think of it as a strict gatekeeper on an assembly line. The scanner checks every single row against a condition you set. If a row passes the test, it stays on the belt, and if it doesn't, it's discarded. Notice the order of these stations. The database engine doesn't read your code from top to bottom like a human does. It first finds the table with from, then it filters the raw rows with where, and only at the very end does it pick out the columns with select. This document highlights a rule for beginners. Because the engine filters the rows before it ever looks at the columns, you cannot use a renamed label created in the select step to filter your data. The engine hasn't seen your new label yet. Success with SQL comes from understanding this mechanical, step-by-step logic the engine uses to process every request. Pulling a simple list of rows is a great start, but to answer business questions, like finding average grades or total sales, we need to move into data analytics. See this messy pile of coins? We use the group by command to organize them. This command sorts identical items into distinct piles, making the data much easier to manage. Once the data is grouped, we apply summary math. Tools like sum, average, or count calculate the total value of each specific stack for us. This transformation is what turns an overwhelming list of individual records into a clear summary that helps a business make decisions. But what if you only want to see the piles that meet a certain threshold, like groups that have more than 10 items? We can't use our previous gatekeeper, the where command, for this. Remember, where only looks at the raw, individual pieces of data before they ever get sorted into piles. Look at the difference in this diagram. On the left, where filters individual pieces. On the right, we have a different tool called having. It acts like a giant claw that removes entire summarized stacks at once based on your criteria. Understanding when to filter the raw materials at the start and when to filter the final packages at the end is a key skill for managing any database. After your data is retrieved, grouped, and filtered, the engine performs one final step. We use the order by command to sort the finished report from highest to lowest or lowest to highest. In professional systems, we don't keep all our information in one giant table because that often leads to errors and duplicated data. Instead, the information is split across several smaller, specific tables. This sheet shows how we keep those tables connected. Every row has a unique ID called a primary key, and we place those IDs in other tables as foreign keys. These act as essential bridges to reconnect different tables on the fly. Understanding how tables connect and how the engine processes your requests is the first step toward working with data at a professional scale.